Paul Abernathy here. Thanks for joining me today. Today we're going to be looking at emergency disconnects. Now, the emergency disconnects when it comes to 1 and 2 family dwellings came into the code in the 2020 edition of the National Electrical Code. Of course, it was discussed during the 2017 cycle, but it just didn't get enough support. Even with a lot of the firefighters, emergency responders behind it, it didn't get enough support. But in the 2020, it came into the code. And here we are now in the 2023 edition of the National Electrical Code. And we want to examine it so that everybody is fully aware of what is required for these emergency disconnects. And we want to show a couple examples because a lot of people seem to be confused. Now, will the requirement for the emergency disconnect bring in some additional costs to the consumer? Absolutely. But this is all in safety for the first responders, people that are coming to structures to be able to, remember, 1 and 2 family, the most predominant that we have where people are sleeping or not aware of their environment and what's going on. And of course, first responders have to respond. And we don't want them going into houses searching for ways to cut the power off. We also don't want them hacking up the service conductors or the meter or trying to pull a meter. They're not electrical experts, so we don't really want them to be working with those energized live parts that typically are not going to have any overcurrent protection ahead of them. So it creates a safety concern. So that was the justification for why it made it into the National Electrical Code. Now, 2023 edition of the NEC expanded a little bit, added a replacement requirement, added some marking requirements, a little clarification, and if you have other power sources, energy sources to the building, like PV or a generator, and maybe their disconnect is somewhere else, it's not grouped with the emergency disconnect location, then you're going to have to put a placard or directory telling people where that is. So we're going to look at that. So we want to make sure that we keep all those things in perspective. So let's go on and go to the National Electrical Code. So here's the NEC, and we're going to be looking again right here at 230.85. This is the emergency disconnect requirement. As you can see, it's 1 and 2 family dwelling only, so that's all it applies to. And it is an emergency disconnect, means it shall be installed. So it's not an option for you to not do it. You're going to have to install an emergency disconnect if it's a 1 and 2 family dwelling unit. Now, in the 2020 edition of the NEC, there was only 230.85 1, 2, and 3, and they're still covered here. There's no change as far as that's concerned of your options. It's just in the 2023, it's a little bit more clarity. You now have broken down into subparts A, B, C, D, and E that kind of break it out a little bit. Instead of it being all lumped into one code rule, it's been broken out a little bit for clarity. So let's look at it. We're in the 2023. So we're going to have the general requirements. We're going to have the disconnect itself requirements, and we're going to look at some examples of these. And then you've got replacement requirement that is new for the 2023. So again, and there's an exception because, you do have occasions where you have storms, hurricanes, any damage that might damage the meter socket itself, the meter enclosure, maybe the service conductors that are coming from the point of attachment down. So, or what's coming up, something might have happened, but you're not replacing the entire service. Then we do have some exceptions here that you can kind of go back and put it back the way it originally was. So good to have some of those exceptions. We do have this new rule for identification of isolated disconnects. This is an example where you have your emergency disconnect for the service, or where you're coming into the building, the emergency disconnect. You do have where you might have a PV or a generator isolated disconnect somewhere else on the structure. It's not grouped here. So if that's the case and it's another power source, then you have to have a placard or a directory letting the first responders know right here at the emergency disconnect where those other disconnects are located. Okay, makes sense? So that's a placard. It's got to withstand the elements. It's got to meet all the requirements of to be if it's raining or whatnot. So people know, the first responders know where to go. Okay, and then of course we have the overall marking requirements, and this is going to tell you what if it's a service disconnect, what you got to put on it. If it's a meter disconnect, then here's what you got to put on it. And if it's a other listed disconnect, which we're going to look at, which is the costly method. But that is another option that you can have for that, and tells you what markings have to be on that as well. So here are your markings, depending on which one you're working with, right? Here down here. And we also have the location where it's to be marked. Now it's very clear that this new language, that the markings have to be on the outside cover. So it can't be inside the cover, hidden away. It's got to be seen. It has to have a red background with white letters. It has to be at least a 1/2 inch high. So it's got to either say any of these. And we'll look at each one of these so we know clearly what our markings have to be. But we're kind of dipping our toe in here. And for you that are just coming into the 2020, this is basically a deeper breakdown. But in the 2020 edition, it's basically just going to tell you that it has to be readily accessible outside. Okay, you're going to get your 3 options of disconnects, and we're going to look at that. It's going to be the same in 2020 as 2023 when it comes to that. A little more language clarity in 2023. But we're not here to look at the 2020. We're here to look at the 2023. So let's do that. So let's go back up here. So the very first thing, let's talk about location. So where does this emergency disconnect need to be on these 1 and 2 families? And it says right here, for 1 and 2 family dwelling units, an emergency disconnect means shall be installed. So it's not an option. It shall be done in 1 and 2 family. Now, a couple ways to comply with this. And again, this has to do with first responders, emergency responders. We do not want them trying to cut the service conductors. We don't want them trying to pull the meter or anything like that. Creates an exposure. They're in this exposure area, and we don't know if it's raining, there's spraying water everywhere. We don't know what the condition. It's not a safe condition for them to be able to shut power off. And I don't want them forging through the structure if it's involved, in a fire or something's going on, and try to find out where the breaker is to shut power. It's just not a safe condition for them. So there's many people that don't like this rule because they puts the emergency disconnect outside. People could shut off power to their house and things like that. And it frightens them. But you can lock it out. If you go look at the definition of readily accessible, it needs to be readily accessible to those that need ready access. So locking it behind a cover still makes it readily accessible to those that need to get there. As far as the operation of the overcurrent protective devices, they're going to operate anyway because they're going to do their job. You hope so. So not really that too much that somebody should be too awful concerned. In a lot of parts of the country, they put the disconnects outside anyway. Whether it's the service disconnect, they could also serve as emergency disconnect. They already do that. But we'll talk about some issues that can generate as well. So, all right, so let's look at here. So locations, where we got to have this emergency disconnect. All right, here's the location. It says the disconnecting means shall be installed in a readily accessible location, outdoors, on or within sight of the dwelling. Okay, so on it or within sight. What is within sight? Within 50 feet line of sight, so you can see it. Okay. Now there is an exception. Now this exception did not exist in the 2020 edition. And this is important because let's say that my service is coming down for this 1 family dwelling and it's remote and it's going to change over to a feeder. I mean, this is very common. I did this quite a few times on houses that back in the day, they did not want everything on the side of the house and we put it remotely, and long story, but we would come underground, change over to feeders, and now feeders would supply the building. Well, in the 2020 code, the emergency disconnect, if you did that and you took the feeder to the structure or the building, then the emergency disconnect would not be at the building. So if a first responder came, they absolutely wouldn't know that possibly they wouldn't see anything. So they'd have to go hunting for where this would be. And so in the 2023 edition, they added 225.41. Now I can add that here so you can see it. It basically has to do with the feeder. If that's your choice, you're not bringing the service, but now a feeder's coming to supply the 1 or 2 family dwelling, then it's basically the same rules, okay? Basically the same rules, but now it applies to that feeder supplied emergency disconnect, okay? So that was added in the 2023 to kind of accommodate that issue where, okay, well, I don't have the service conductors coming to the building, and I still have the same hazard, and somebody might not know where that service equipment is. So, or the emergency disconnect is at that point. So at this point, what about putting it at the structure? So that's where this one came in. So that's what 225.41. Now, if you're using 225.41, then this location rule doesn't apply. None of that applies because you're doing it to the feeder and you're skipping this one and you're actually doing it with 225.41 for the feeder. Make sense? So if you're bringing a feeder to the building, then you're going to be shifting to 225.41 for that emergency disconnect, okay? And ignoring this. Okay. Now, assuming we're back at the emergency disconnect, just where we got service conductors coming down from the point of attachment or under from a service lateral. Next is the rating. So that disconnecting means, and you notice that it goes out of its way just to say disconnecting means. It's not saying service disconnect, it's just saying disconnecting means. It says, okay, the disconnecting means shall have short circuit current rating, that's SCCR, equal to or greater than the available fault current. So typically for residential, they usually try to guarantee it. It's not going to exceed 10,000. So AIC, but you know what? Check with your jurisdiction, look at what you're doing with. Just make sure that the disconnect that you choose is equal to or greater than whatever they give you as the available fault current. And typically we get that from the utility. They supply that information. So just make sure that you have that. Or they might give you and say, we guarantee that we'll never exceed 10,000. And then you make sure your equipment's at least that or greater, then you should be okay with that. Okay, but again, that's something you have to check with your local jurisdiction and local utility. Next, as far as grouping it, if more than one disconnect mean is provided, they shall be grouped. So another grouping application where we're trying to get them grouped here for this application. Again, very critical if we're talking about something like a two-family dwelling, but here we want everything to be grouped, all right? Now, next we get into what's called the disconnects. Now, this is pretty much mirrored on what you had in the 2020. So the other stuff was kind of in the language itself in the 2020 edition of this in 230.85. It was all written in the verbiage, so you had to pull it out. So all they really did was extract it out and put it into this kind of format. That's all that really took place. Now, the disconnecting rules, which the different types of disconnects that you can have. Now, the first one being a service disconnect. And that service disconnect could serve as the emergency disconnect and the service disconnect. So what are your options here? Well, in many parts of the country where they put the whole panel outside, it's got a main breaker, and that's your disconnect. That'll be the emergency disconnect. Plus, it is also going to be the service disconnect. It's going to provide overload protection to those service conductors. Okay, it's not going to provide any short circuit ground fault protection, but it's overload protection, which is required by 230.90. So it's meeting that. And then everything after it, you have all your breakers. Okay, they're basically going to have your breakers, and then you'll have your branch circuits coming out of it. All right, so that could be your service disconnect, and that's going to be your service equipment, and it's going to be your emergency disconnect. And he'll show you what you got to do to label it here in a minute, if it is, that's what it is. Now, that's probably what people do with the NEMA 3R exterior panel board type of application, right? Well, another option is to simply put a main breaker, 200 amp, let's just say it's 200 amp, a 200 amp disconnect outside. That is also the service disconnect, but it's also the emergency disconnect. And I don't have all the breakers in there. It's just one main breaker. Now, once you come out the load side of that, that's a feeder. And the feeder is going to supply the rest of the building. So let's kind of look at what one of those would look like. And this is how I would do it. Now, is that going to add some additional cost to the install? Well, of course it is. But again, I'm going to get rid of a lot of problems that people have by putting the exterior NEMA 3R. And then you got to worry about how do you get those cables into it? And if it's installed on the side of a building and it's got that 1/4 inch gap in 312.2, then how do I transition and meet the code? I mean, obviously, we've talked about this, 312.5C1, you can't take all the non-metallic sheet cables through one knockout. That's not compliant. And if you were to try to punch holes in it, you can't take all of those NM cables out the building, and then that small little 1/4-inch gap is going to put you in a wet location, so you can't install NM cable there. So it makes it more complicated to do this compliant. Whether somebody allows something or not, it makes it more complicated. So I'm like, okay, well, I want to make my life easier. Plus, you know me, I don't like the breakers being on the outside. You may love it. Your state might be all you do. I don't like it personally. So I'm an electrician, my choice. I'm not going to do that. So what am I going to do? I'm going to go this route. So I'm going to get me, and it's no particular brand. I just picked one. You know, this one happens to be a Siemens, a great company. Speaking of a plug, in a couple months, Vince Delacroce, who actually is the code expert for Siemens, is going to be coming here to the studio, and we're going to be doing swimming pools, spas, all the changes for 2023. It's going to be awesome. He's going to be with me again, and we're going to redo that entire series, and it's going to be awesome. So I'm looking forward to Vince joining me here at the studio so we can get that all done. All right, so let's look right here. So here we go. This is an outdoor main breaker, as you can see right here. Okay, there you go. It's just a 200 amp. That's it. And when you look inside of it, I'll give you a little sneak peek here. As you can see right here, you've got the service conductors come into the lugs, and then the load side at the bottom is where your feeders are going to come out and going to supply a panel, either inside, just inside, or maybe even somewhere else in the structure, right? But this is the only thing outside. Now, this is the service disconnect. Now, if you look over here on the right, and I can't, right here where my mouse is, although I'll try to move it a little bit to the right. So right here, you move it to the right. See there, it's got that hole. So that is where you're going to put your main bonding jumper. And this is the service. It's suitable for use as service. And this is going to be my service equipment. It's going to be my service disconnect, my emergency disconnect, and then it's going to create a feeder on the load side of it. Okay. And that's going to feed my panel somewhere else, which could be main lug only if I want, because I've got the protection upstream. All right, so, and of course that might save you cost-wise because you don't need another main breaker. Now, if you want to get a panel with a main breaker because of cost and supply, that's okay too. You can have two. That one's just going to be basically a switch, even though it's probably still going to have an overcurrent rating on it, but you get my point. This is an option that I would go with. I'd install this on the outside, turn it into a feeder, and I can put my panel anywhere I want inside that dwelling. If they still want it on the other side of the wall, that's fine. But I don't have a limitation on how far my feeder can go. But I do have limitations on how far service conductors can go inside of the building, okay? 230.70A1. So at this point, this is what I would do, right? So this is a service disconnect. It's just one 200 amp breaker. Yes, okay, cost, right? Because everybody saw the cost here. An additional 174. Prices are going to vary from different manufacturers. This is Siemens. I think this was at Home Depot. I might have gotten where I got this example from. But this is just one option, okay? So keep that in mind. This is just one option to be aware of. And you really can't see the label, but on this label, it says suitable for use as service equipment. But there's something important about it. It does not say on it suitable for use only as service equipment because it has the ability to remove the main bonding jumper, that connection to the grounded conductor, right? So that's important. We'll see that a little bit later when we're talking about the different options for disconnect. So this is the first one. This is what I would use as a service disconnect for me. Now, again, you could put a NEMA 3R panel with a main breaker and breakers in it. That's your option. It's just more difficult to figure out how I'm going to get my cables into it, right? Than something like this. So an additional $174, I don't have to worry about it. I just take some SER on the load side of this thing in and hit a panel, and then I don't have any problems, okay? I'm willing to pay $174 to not worry about the headache. And I want the panel where I want it. For me, I just don't like it outside. You may love it outside. That's just not me. It's the beautiful thing about it, right? To each his own. Okay, so let's kind of look at the next option. So the next option is a meter disconnect that is integral to a meter mounted equipment not marked as suitable only for use as service equipment, installed in accordance with 230.82. So I could have a meter disconnect that is integral to the meter mount equipment. So it's all integral, and it is really just a meter disconnect. That is it. Right? Now, don't confuse the meter disconnect with a bypass, right? If you go to Millbank, you can learn a lot about the difference between a disconnect and a bypass. A bypass is designed to be able to just interrupt to the point to take out the meter, but it doesn't interrupt power to the dwelling. It's just so they can remove power from the meter so they can safely remove it. That is not a disconnect. It's not intended to be a disconnect. So just because it might have that lever. Now, you can buy equipment that is a lever or what we call a hook style that you can use that basically is the bypass, and you can buy bypasses that also have integral meter disconnects in them, right? So they can bypass it and not have to disconnect, but still remove the meter. Check with your supplier of your meter, but again, this one is not the one that I recommend unless the power company is going to supply it with it, give it to you, all right? Now, you might be in the parts of the country where it's all integral, and chances are if it is, then you're going to have a meter with maybe a bypass, but it's also going to have an actual meter disconnect in it. Now, that may or may not also be service equipment. It depends on the meter, depends on the assembly, the combo. It might have a main breaker, and it might say in it that it's suitable for use as service equipment, and it might have breakers underneath it, okay? That is all dependent on what you buy. All this rule is saying is if you have a meter disconnect and it's part of a meter mount equipment, if it is just a meter disconnect, it is not service equipment, okay? And why is that significant to us? Because with that service disconnect one we just explained a little bit ago, once it gets on the load side, it's now a feeder. So you have 4 conductors. You'll have an equipment grounding conductor, right? Because now we have a breaker that we could trip, that 200 amp on the load side. With the meter disconnect, it is not, okay? It is not going to be service equipment for just a meter disconnect. Now, again, you can buy combos that are more than just a meter disconnect, but we're just talking about a meter disconnect, folks. That's all we're talking about. And it says it very clear right here. It says a meter disconnect integral to the meter mounting equipment, not marked as suitable only for use as service equipment. So we don't want it to be marked that it is only to be used as service equipment, okay? That's not what you want because we're not using it as service equipment, right? And then when it makes reference to 230.82, the whole intent of that is it's going to be on the supply side of the service disconnect. That's the whole nature of 230.82, right? So that makes sense. So it's not a service, and we have to mark it accordingly, and we'll look at how you mark it here later. Now, the next one is, to me, the most costly. I'm going with that service disconnect like I showed you. It's $173. I'm going with that. There are other listed disconnect switches, circuit breakers that are marked suitable for use as service equipment. So it has to have that marked in it. And most of them will, even a lot of those safety switches will, that say it's suitable for use. But it cannot be marked as only suitable for use as service equipment. Okay? Very important. We have to make sure that it has to be marked suitable for use as service equipment, but it can't say that it is only to be used as service equipment because we're not using it as service equipment. We want the ratings. We want to make sure it is SUSE rated, but we're not going to use it for service in this case. All right? Okay, makes sense? And also you got some information on, and it reminds us again that with all that said and done, it reminds us again that it's being installed on the supply side of the service disconnect. So we know that it's not the service equipment. And we're going to have to mark it accordingly. So you have these 3 different offerings. So what does this kind of switch look like? What are we looking for? All right, let's kind of look here. So here's another one. We're going to stay with Siemens brand since we're working on this. So here is a 200 amp, 240 volt, 2-pole, non-fusible safety switch. All right, here's what it looks like, and here's what your labels look like. And this is here you see it. It's a safety switch. It's non-fusible. It's listed. And remember what we said? So here it is, the label on it. Notice, look at the top. And I will try to make sure I can get over here so you can see it where my mouse is, right here. Let's look at it right here. See what it says right here? Suitable for use as service equipment, right? Right there. All right, now, why is that important? Well, because that's what it said. I could use this switch. And remember, it's non-fused. So it's not providing any overload protection that's required by 230.90. It's just a switch. It's just the emergency disconnect. And so, again, that's what it kind of looks like inside. And that's all it's serving. It does not say on it anywhere that it's suitable only for use as service equipment. It doesn't say that. So I can use this one here. Now, the difference in why I'm not going to use this one, for me, is that price right there. Why the hell would I do that for $173? I can just go in and kill two birds with one stone. I get a service disconnect and emergency disconnect. And say, so this is just an example, right? Notice it says suitable for use as service equipment, okay? All this kind of stuff. So at the end of the day, this is a non-fuse safety switch, which is a listed switch, right? So we come back, and it is, again, it is other listed disconnect switch or circuit breaker. In this case, just a switch. Perfectly okay. Meets all the requirements, doesn't say that it's suitable only for use, but it does meet the SUSE rating. It states that very clearly. I could use this. So this is an example of B3, if you want to do it. Again, my choice, and please don't let me sway you. I'm going with this one, and I'm going with that 173, service disconnect and emergency disconnect combo, and I'm going to change over to feeders, and I'm going to put my panel inside where it's easy for me to get cables to it. I don't have to worry about trying to get outside and all that kind of other stuff. So that's how I'm going to do it. All right, now replacement. So in the 2023 edition, we now have a replacement rule. It says where the service equipment is replaced, all of the requirements of this section shall apply. So we have a retroactive rule here, whereas if you're going to replace the service, upgrade the service for any reason, then we're going to have to meet this rule and put this, again, 1 and 2 family only, we're going to have to put this emergency disconnect in. And I've got my options, as you saw, different options to do this. But there is an exception, as we talked about earlier. If I'm only going to replace the meter socket, or I'm just going to replace the service conductors that are coming down, or I'm replacing the raceways or fittings that are associated with those service conductors and all that, basically maybe in a storm or tree has fallen or something happened, but I'm not replacing the panel, I'm not doing any upgrade there, then I'm okay to put it back the way it was. That's basically what this is saying, that under the exception, right? But if I'm going to replace the service, then then the exception's not going to apply, and I'm going to have to replace it. Now, here is the identification rule that we talked about. I touched on it at the beginning briefly. It says where equipment for isolation of other energy sources, and again, it gives you some reference down here in the informational notes. That's why I love informational notes, by the way, is they should give you information, not enforceable, but give you like roadmaps to other relevant things in the NEC. So it's talking about generators and things like that, battery systems, interconnected power sources and 705 and whatnot. So if I had a PV or I had a generator or I had something else with their disconnecting mean requirements, and it wasn't located right here where my emergency disconnect is, then again, this is where I have to put the placard or directory directing the first responders to wherever that other energy source disconnect is so that they can shut it off. That's the last thing we want to do, is have them shut off the power and then the generator kick in and re-energize everything. Because you remember, they're coming to the structure. They don't know what the hell's in there. They don't know what's going on. They're not electrical experts. So again, this is just a safety thing, and it makes sense. So if they see a directory, then they know, oh, wait, we got other things we got to shut off. Makes sense? And that's the whole purpose there behind that. So this is kind of paraphrase that one for you. Feel free to pause and read it if you want. And lastly, that's these markings. Now, before we told you in the 2020 that we had to go back and look at 110.21b, and that's legibleness, and has to be designed to handle the environment to where it's installed. Wet location, you're obviously not going to use labels that are inkjet or easily going to be smeared or going to be become illegible. So we have to think like phenolic labels, metal painted, screen printed type of labels, whatever. We have to start thinking of something that's going to be there on the outside of the cover so that anybody could see it. So let's talk about that. Now let's look at the markings. Now we told you the different types of disconnects, right, that we have. So if we went with our service disconnect option, whether that was the one I told you about, the single breaker outside and the single enclosure, or a NEMA 3R panel with a main breaker and breakers, however your flavor, then we have to put the markings emergency disconnect, because that's what it is, meeting 23085. But if it's also the service disconnect for the dwelling, then that is also got to be marked on there as well. Now, if we chose the meter disconnect option that is permitted by 230.82.3, then I have to label it as an emergency disconnect. I have to label it as a meter disconnect, very clearly that it's a meter disconnect, and it's not service equipment. It is not considered a service, just like a meter enclosure is not considered a service. All of that. Now, I'll remind you that all this is also regurgitated in 230.82.3. If you go read it, it's all regurgitated again. Remember, the whole intent of 230.82 is to be on the supply side of the service disconnect. Thus, the meter disconnect can't be a service disconnect, so we have to mark it as such, right? It has to have all of these things on it. Now, the last one was that example of that expensive switch that we told you about, non-fusible, okay, is an example that you could use. Could be a circuit breaker style. They do make circuit breakers that don't have overcurrent rating. They're just simply nothing more than a switch, okay? Now, with this one, it has to be marked emergency disconnect, and it has to make it very clear that this is not service equipment, right? It's not. If you have 3 conductors coming into it through the meter, into this switch, 3 conductors are going to continue on. They're not feeders based on this configuration, all right? Because it says, okay, that it's not used as service equipment, all right? All right? All right. Now, what about the marking? All this you see here is exactly what you're going to print on these labels or these little markers, okay? Down here, it's the location and the size. So right here, it says this marking or label shall be located on the outside front of the disconnect enclosure with red background and white letters. So you get these pre-made. You're not going to do it in a Sharpie. Again, 110.21b is going to say it's got to be, it can't be handwritten, so that's not going to work for you. It's got to have a red background, white letters, and those letters have to be at least a ½ inch high. So we're taking a little cue here from fire alarm circuits and everything in 760. So it's got to be red background, white letters, at least a ½ inch high outside of the disconnect so that anybody going up to it can see it. We know exactly what's going on, okay? So that's what we've got in this application. So that's your changes to 230.85. I think it's a great change. I think that it really solidifies why we need this emergency disconnect. And again, 2020 was a great start. It kind of tells you everything you need. But in the 2023, it's just, you know, people ask why. Let me come back to me real quick. People ask, why do we change every 3 years? Because a lot of times, have you ever written something and then you look at it and you go, you know, I can say this a little better, or we can be a little clearer. And then you got to, once it's through the process, you don't catch everything. So then they're like, oh, let's take another stab at this and make it even better. And that's what happens. And then people all over the country, experts like Fred Hartwell, who is really into this type of thing, you know, people like that who are experts in the industry, and even you out there who have your knowledge, maybe you have extra knowledge in certain things like this. Maybe you're the firefighters and you really know that this can save lives, especially to the firefighters, first responders. Then you're able to submit something to modify it or change it to make it sound better, make it be a little easier flow. That's what we're after. So it's not about people just trying to get things into the code. Sometimes clarity is needed to make something easier to understand. And that's the case here with the 230.85. All right. Okay. Hopefully you got something out of it and I didn't bore you to death. Hopefully you follow us on all of our social media platforms. If you need a good electrical code class online, go to fasttracksystem.com. If you want to see a lot of our videos, then you got to go to Fast Tracks Tube Tube. Take the system here and replace it with tube.com, and you can get all of our exclusive videos. Make sure you become a subscriber. We'd love to have you. Again, thank you for watching. Until next time, folks, stay safe. God bless.